Welcome to your lesson on probability, union, and intersection. I have some important symbols that we're going to use. This is the language of sets, but we use it in probability. First of all, we have intersection. Intersection looks like this. This is the A intersection B. It can also be read as A and B. What this represents is events that are A and B occurring at the same time. So looking at that as a Venn diagram is probably the easiest way. Here we have characteristics of whales in this circle, characteristics of fish in this circle. And there's an overlap. There are some characteristics that both whales and fish have. And that's exactly what intersection is. It is the area in a Venn diagram that represents where both things are occurring. So here we can see in this zone here, the overlap is where A and B both occur. And that's what an intersection is. Next, we have union. Union looks like this. That is often read as A or B. Sometimes when you think of something or something, we think, for example, here are the traits of whales or the traits of fish. So you might think it's only this part and this part. Don't make that mistake. In probability language, when we say A or B, we mean this one or both of them. So that's what it says here, events A or B or both. So a diagram for that would be this. You shade all of A things or B things or the things in the middle. So this is A or B. That's the union. Next, we have the complement. The complement looks like this. The complement of A can also be read as not A, and that means event A does not occur. For example, here's set A. Not A would be everything outside of set A. So notice it's been shaded all outside here. Okay, in our situation here, if we said not whales, you would look at everything outside of the whales characteristics. So basically, you'd just be looking at these three characteristics here. Or if there was more outside here for other mammals, we could look at those. Okay, finally, we have conditional probability, which looks like this vertical line. This is read as A given B, or A given that B has occurred. So event A occurs given that event B has occurred. This one's a little harder to see on a Venn diagram, and if you're just starting with probability, this will be a little bit harder to understand, but here's what it looks like. First of all, to find A given that B has occurred, we find out the portion of A that has occurred that is also within B, because A given that B has occurred means we're looking for all the A things, but we're only looking at the A things that are within the B circle, right? So here's A intersection B, so that's the A things that are within B also, and then we divide that because we're finding a probability of all the B things. So basically we're saying what part of B is also A. Again, tough to understand at first, but you'll see it when we do some examples how that looks. Okay, first one to try. We've looked at this situation already. We have all these students who take either environmental sciences or what's the other class? Geography, I think. Yeah, geography. So this big oval is labeled E. That's all the students taking environmental science. This one is all students taking geography. And I guess there's another one here. S. What is S? Spanish. Students studying Spanish. Okay, we've done this before in the last lesson, but basically you put all the names in the right places and we have this. And in that last lesson we noted that sometimes it's rather than listing all the potential things within each set, it's better just to give the numbers. So here we had 2 people, so we put a 2 here. And here we have 3 people, so we put 3, and so on. So let's use this diagram to try a problem. So here's that diagram again. Now we're looking for these things. Again, make sure you're familiar with the language. Here's intersection, here's union, here's not or the complement, and here's a given that. Okay, so try A. Let's see if you can find out what is the probability from this group of selecting a student where there is an intersection of environmental science students and geography students. Let's give it a try. Okay, the answer to that is 1 out of 11. So if one student was selected randomly out of this class, first you have to say, well, how many students are there? And if you add up all the numbers, including these students here, there's 11 students in total. And E intersection G means what are the students that are taking both environmental science and geography? That's the intersection right here. So 1 out of all 11 students. That's the probability. Try question B. And try C at the same time. No, actually B, just B. Okay, for B, hopefully you got this. The union, as you remember, is both circles shaded. So we're looking for the union of E and G. So here's E, here's G. So you're looking for everything within both of those circles. If you add up all those numbers, you get 9 out of the total 11 students. That makes sense because there's only 2 students outside of E and G, and those are your leftover 2 to make 11. Let's try C. Okay, in C, we're looking for the complement of E. We know that E is if you add those up, 1, 3, 2, that's 6. So the students in environmental science is 6 out of 11. So that means those not in environmental science is the full probability, 100% or 1. 1 minus those that are in environmental science leaves us with 5 out of 11 not. Of course, you didn't have to do 1 minus that. You could have just counted the number, everything outside of E, which is 2 and 3. That makes 5. Either way is okay, but it's important to know this rule about complements. And finally, try D. Okay, in D, like I said, these are often a little bit tougher the first time you see them. So we're looking for probability E given that G has occurred. Basically, what that means is represented very well in this diagram. We're looking for the students who are taking environmental science, but given that they are a geography student. So in other words, we're only looking at geography students now. So we're saying what students have taken environmental science out of the geography group. So what this symbol basically does is it reduces our sample. In the beginning, we're saying we're looking at all 11 students. So in the previous problems, we always said some number out of 11 students. But now, the given that says, let's reduce the students we're looking at. Let's look at just geography students. And now how many of those students take environmental science? And that's what we have here. 1 out of 4 geography students takes environmental science, and that's what that symbol means basically, so 1 out of 4. However, this one is different than the previous questions. Let's go back for a minute. In all these previous questions, these two were identical. E intersection G is the same as G intersection E. We're just talking about that overlap no matter which letter you put first, doesn't matter. In the second one, same thing. The union of E and G is both circles combined, and that's the same as saying the union of G and E. Same thing, backwards or forwards. And finally, in this one, it's not the same. If we look for the geography students given that they're environmental science, that's different than what we just looked at. So now we're looking at geography students out of the environmental science group. So now here's the environmental science group. It is a group of 2, 3, 1, that's 6 students. And there's only 1 geography student in that group of environmental science, so 1 out of 6. So take a close look again if you need to. We have 1 out of 4 and 1 out of 6 for those two. Please study that carefully. That's a tough concept for many students when they first see it. Okay, next, let's summarize these important formulas. You should write these down for sure. For disjoint, which are also known as mutually exclusive events, which look like this. There's some things that happen here, some things that happen here, but there's no overlap. Those are called mutually exclusive. They don't share anything in common. For the probability of A or B, again, using union for or, the formula is just A probability of A plus probability of B. We just add those numbers plus those numbers, and that's our total for our probability. When we want probability of A and B, remember that A and B means intersection, and for mutually exclusive, there's no overlap, no intersection. So the intersection is 0. I want you to think about that backwards. If you ever see a question ask, how do you know these things are mutually exclusive? Well, if you found out that the intersection does not exist, you can say, well, they must be mutually exclusive. Now let's look at inclusive events, all right, which means there is an overlap. For or, again, union. In this case, the or formula is really important to notice. It has A plus B, so just like we saw a moment ago. However, now we subtract the intersection. The reason for that is when you add this circle to this circle, you're counting this overlap zone twice because it's part of this circle and it's part of this circle. So to get the union, which is everything within these circles, we're going to subtract away this overlapping zone because we've actually counted it twice. That's a key formula. Make sure you know that one. For A and B intersection, it's the same formula, but you can see reversed. Basically, we took this part, moved it to that side of the equation, and that moved to that side. Same formula, we've just switched these two. Finally, complementary events. As you may remember, we have A and here's not A outside of it. And for that, we need to know that they are mutually exclusive, right? They cannot occur at the same time. This occurs or this occurs, they can't overlap. And therefore, this plus this equals 1. The probability of this one plus this one equals 1 because all these things plus all the things outside of it make all the possibilities, which is a probability of 1. Okay, let's look at some examples. Please try the first one. Okay, hopefully you looked at it. You said union. We're looking for OR, so union of these and these in a deck of cards, and therefore we have 4 out of 52. Well, you have to know a deck of cards has 52 cards, but 4 out of 52 are 10s, 12 out of 52 are face cards. We just add those up. We get this number, which reduces to this. Now let's try here. Now these are not mutually exclusive, so make sure you use the correct formula when you're doing OR. Okay, so you're looking at union. Now we use this formula because there's an overlap that we need to subtract because we counted twice. So the probability of face cards plus the probability of spades and then minus the overlapping zone gives you this number, reduces to this. Again, if you got that wrong, just take a close look and make sure you understand why this formula was used here and this one here. Next, take a look at this problem, sketch a Venn diagram, and see if you can find the probability that an item selected is spicy and vegetarian. Try it out. Okay, so here's your Venn diagram. We have a universal set, which means all the menu items, 40. Here is our spicy items, 14. Here are our vegetarian items, 9. 23 are neither spicy nor vegetarian. And we know these overlap because when you add 14 and 9, it's 23. And then you have 23 out here, and that makes more than 40. So anytime everything in here adds up to more than 40, or more than what you know is your universal set, you need to put the overlap. So now we also know there must be 6 here. And the way to get that number is when you add 14 and 9, that makes 23. And again, there's 23 here, that makes 46. We know we're 6 above what we should be, so that 6 must be the overlap. Okay, so this gives us 8 here because these have to make 14. And this gives us 9 here because this have to, sorry, 3 here because these have to make 9. Okay, so probability of spicy and veg is this intersection. And we can write the whole formula even though we see it on the Venn diagram. The formula for intersection is this. Remember, it's the opposite of the union formula. We add those up and subtract the union. So probability spicy, 14 out of 40, vegetarian, 9 out of 40, and then subtract the union, which we know is these numbers added up, and we get 6 out of 40, which matches our diagram, spicy and veg. All right, this is a trick question. Try it out. Okay, so hopefully you saw this. They are mutually exclusive, therefore there is no intersection. It is 0. And last two, draw a Venn diagram here, try B and C. Here's your Venn diagram, check that out. And then B and C, check those answers. C is particularly important here, we mentioned that. There is no intersection. And then D. We're looking for the union, we know they're mutually exclusive, so there's our union, we just add them up. Last one, try this. Try A and A first. Venn diagram looks like this, check your work. And then try B and C. There's our answers. This time there is an intersection, therefore this is the answer for C. Study carefully. Now try D. And here's the union formula, there it is.